Okay, let's begin. Welcome to the second in a series of webinars presented by Syntris. The idea of this webinar is to further our knowledge and the uses and applications of powder metal and its components and how powder metal might be suited to your business. I'd like to introduce myself. I'm Phil Goodwin, the president of Syntris, and online also is Rick Armstrong, a sales manager and applications manager. Between us, we have about 65 years of powder metal experience, and certainly are here to answer any of your questions. Today's agenda: why PM? Why would you choose PM? We're going to review why you would use it and what the benefits are. A net shape or a near net shape. The intent of powder metal was to have a net shape component. In other words, not to have to machine it. In some cases, though, the tolerancing becomes when you get into 10,000ths of an inch or 10 microns or 8 microns. Then you become to the point where secondary operations may be necessary. It could also be useful for finishing. Could be for hardening. There are several reasons you'd use powder metal secondary operations. We're going to give you 4 good reasons why you'd use secondary finishing. Reasons to select Syntris as your secondary finishing source for your powder metal applications. And we're going to give you some best case applications, have an opportunity for question and answer. It's founded in '72, serving automotive, industrial, and consumer markets worldwide scale. We ship to many countries around the world. We do manufacturing of the PM components as well as secondary finishing ends and sub-assembly. We're located about an hour from Detroit and about 40,000 square feet under roof. Powder metal advantage. Why choose PM in the first place? Well, in previous webinar, we discussed this, taking powder from its original state, which you see on the top left, to its finished product, which could be after the sintering operation, but also be after secondary finishing, where you've taken a component from a finished block, from a single block to a finished detailed part. The intent, of course, with powder metal is to get to a simple net shape, but in the cases, again, of required secondary operations for tighter tolerances, this is what happens. So we took parts from powder through compaction to the sintering process and then secondary finishing. So why secondary finishing? Why would you do it? Well, the tolerances may become too tight for the powder metal net shape component to hold. When you get to that point, for example, and again, it depends on the diameter of the component, but if you've got a 3-inch, 4-inch outer diameter component, you can't hold much more than perhaps 8/1000ths of an inch in tolerance. And if you need to get tighter than that, then you may have to add secondary machining. In the case of the component you see before you, that has, I believe, 8/10,000ths of an inch of tolerance on the diameter. And that thing is rough turned, fine turned, and then ground precisely on lengths and diameters. Also, why would you do it? You want to have secondary parts assembled. So you want to take that and make a finished assembly. So the objective should be to get components assembled as this one is, for example, where we actually manufacture the small component that goes on the top. We purchase a specific form pin that is pressed into the component and holds that component in place. Also, secondary finishing, you look for single source solutions. The objective should always be to keep the cost down, and single source solutions are something that's important to most customers. And don't try it at home. Powder metal is not like machining wrought material. It has its nuances. It certainly can cause, you can have issues with damage or breakage that you wouldn't see on a standard component made out of wrought material, simply because of the nature of powder metal, where there's a degree of porosity in the component. So effectively in powder, you have components made of particles of powder separated by small voids. So each of those particles becomes a hard component to machine. So each time the insert from a machining insert, for example, hits those components, those small particles, it's like a hardened strike on the part, which can break down the inserts. So that's something that we at Syntris certainly have learned over the years, and we feel that we're as good at turning or machining powder metal components as anybody in the world. secondary and subassembly operations. These are the things that take place in our operation. You can see our operator dancing for the show. But certainly we do pretty much everything from turning and milling and grinding to hardening, impregnation. We do coating as well as green state machining. Now, I'll talk about green state machining in a little bit because it's something that's not proprietary, but certainly something that we do relatively uniquely. As far as sinter hardening and steam treatment, which is the next operation after the pressed or briquetted component. During the sintering process, it's possible to take that component and rapid air cool the component after the heating process, and that will yield a component that has a hardened surface and apparent hardness of about Rockwell 35C, which is in the neighborhood of where you'd expect to see through hardened components. So it's cost effective. It happens within our facility. And the components don't go outside. They're not subject to the occasional damage that you see from typical heat treat operations. And you end up with a hardened part that's much cleaner and certainly not covered in the oil or soot that may often result in through hardening or case hardening. Another opportunity is with steam treatment. Steam treatment increases the hardness slightly on the outside of the component because it places a steam oxide coating where a high pressure steam oxide is introduced to the surface. Steam is introduced, the oxide forms, and you get that blue colored component that has a slight bump in hardness and a little bit of rust inhibition. So you get a few more hours of salt spray durability, and actually the idea of the key for coating comes from steam treatment. Steam treatments, the oxide actually holds the coating in place so that it doesn't peel off if you're having some specialty coatings. Now I want to talk a little bit about green state machining. Relatively unique in our industry is what we do with our green state machining. We worked many years ago with a major powder supplier to develop a process for machining parts prior to the sintering operation. In other words, when they're still basically like a raw cookie that could be broken. Effectively what happens is that the parts are then glued together, the particles are glued together, and then the machining can take place, as you see in this component, where there's actually a groove cut between a full-length tooth. And the idea with the groove cutting is to certainly make it cheaper and faster, because we can cut it faster. We can certainly make it less expensive, because to cut that severely interrupted cut in a tooth on any component, whether it be wrought or powder metal, would be expensive in terms of inserts. And yet we can take the same component, do it in the green state, and then we can sinter harden it to yield something that looks more like this, which, although in function isn't normally a sinter hardened part, but this one has been sinter hardened. It has that typical gold finish that you see in a sinter hardened component. So you've taken a part that's been machined, a groove cut between teeth so it can have multiple chains run on it, and at the same time it's been machined in the green state, which causes much longer tool life and generally lower cost. It adds an operation for curing because that's necessary in order to make the powder stick together effectively for the machining, but that's not a high-cost operation, and generally it runs a little cheaper than solid-state machining. So let's talk a little bit about what's next in machining, hard turning or roughing. You see a component on your right that is the as-pressed component. Now, there's a couple of reasons for that component being made that way. Most of the reason is because of powder distribution. So when you press a component, there have to be places for the powder to be able to go within the pressing tools. So it has to be displayed somewhere. You couldn't press this form into this part. Perhaps some of it, but not much of it, and the powder distribution wouldn't allow it. And so in order to make it a more robust component, you press it as you see on the right. On the left, you see the rough turn component. In other words, if you don't need a super tight tolerance, that might be enough. The rough turning, maybe the surface finish isn't quite so critical, so we can hog that material out a little quicker and do it a little cheaper. And the idea would be that it would be less expensive to the customer and ultimately makes a better product with the tolerancing necessary. Here's a good shot of the rough cut where that same component is actually being cut in the rough state. And if we couldn't press it, we had to machine it. In this case, it needed to be machined to maintain the robustness of the component. Now, finish cut. Hard turning may be necessary. In both cases, this is hard turn. The material is sinter hardened component. However, the rough turning is done with a different insert, different speeds and feeds. The fine turning of a finish cut is a very tight, smooth finish that will give you a much more consistent finish for perhaps any requirements of bearings or anything like that happens to be, or something runs on the component, and also for tolerancing. So the idea, the objective of the fine turning is, in this case, we not only turn the outside diameter, we also cut an additional groove because of the insert type, and we also give it a very fine finish, and that gives you that enhanced surface finish. Now, beyond that, the same component is then taken to a grinding operation, usually an angle grinder, an external angle grinder, that's with a customized wheel that's designed to hit 3 surfaces at once on this component. And the objective with this component is then to take that and grind the OD to ensure that you've got perfect roundness with a very tight tolerance, less than 8/10,000ths of an inch on those diameters. And it's, when the requirements do go beyond those things that you can achieve with turning, grinding may be an option, and it certainly gives a nice finish. So, from powder to finished product, you saw this component. Here's the component that we manufactured. You can see what we've got. It's a solid part that was pressed basically for robustness. And then from that step, it went through the process to a finished component. So then you can see the finished component, which is now an assembled, fine-turned, round diameter, grooved component with an assembled piece that actually meshes with another component, needs that flexibility. So we've taken that component that we actually make and assembled it into the fine hard turned external. Both of these, again, would be Rockwell 35C in finish and hardness. So in cases where there is no opportunity to turn the part, in other words, the part can't rotate because of the configuration or because of the desired configuration of the feature that you want to place into the part, you might want to do vertical milling. We do a significant amount of vertical milling that allows us to make oblong shapes or cut, S-type or infinite shape grooves into flat components, and allows us to do a variety of things, up to and including brushing of components, which is something that we've only just recently gotten into using as a prep for gears. The next step might be fine grinding. Now, what you see before you are precision pump plates that are held to about 4 or 5/10,000ths of an inch in tolerance on the length. And those components are fine ground in a machine that's dedicated specifically for their application. Could be used for gears, could be used for pump plates, could be used for gerotors. There's a variety of things that can be done, and it's also capable of lapping. So it's very close to a lapping operation, which is a very fine, very low material removal component operation. The objective here is obviously to give us consistent quality, and this is something that's monitored during the process by the operator. As people often say, grinding is almost a fine art, and in this case, we find this to be true. So let's talk a little bit about our finishing. We like to think of ourselves as putting things together in cells where it makes sense. You can see the flow of the componentry. The part that we showed earlier, there's a raw pressed material going through our first operation of the rough turning to our second operation of the fine turning and the grooving and the prep for the grinding operation, which is the final operation. So we've got a simple, straightforward flow of components, single piece. We do the same thing with other major volume components where the parts are flowed through the system with an intent to yield the consistency that's necessary for what our customers demand. We also gain the labor efficiency. although it looks like there's a lot there, but that's actually, the cell is operated by 3 people on a normal basis. You might see some training going in there taking place. Quality, we measure it and we guarantee it to the best of our ability. We verify what we do using CNC-controlled CMMs as necessary. We also have in-process gauging, and we certainly value the use of attribute gauging to ensure fit function capability for the customer. Very often, tolerancing is laid out. What we've found is tolerancing may be laid out by engineers for one practice, but by the time the part gets to finished, that may not be the case. The part may not fit, and attribute gauging can often benefit in use there. So what's the bottom line? Single source solutions. The idea is to keep the part from going around to different locations. We've used secondary machinists in the past, and we've had, let's call it spotty luck in our use of that, simply because they mark it up. There are costs that ensue as a result of that, and there are also markup margin that they apply, and potential risk in terms of stock that could be out of tolerance and large inventory in process. So there are a few steps with a PM near net blank. That's another benefit to secondary finishing. I mean, near net gives you very close to it. The components you see have some green machining on them. This has been green machined. The other component had some green machining that you can't actually see because it's flipped. But and then the other part that's in the middle there is a hardened hub that is actually, it shows a good example of a lot of PM applications in the machining operations, grooving, honing, turning. There's a fair bit of operation there. And there are fewer external vendors. In other words, less freight, one margin impact. I've already mentioned that an external guy is going to mark it up again. We don't do that because, clearly when they mark it up, you mark it up on top of that, and customers don't want to hear that and don't want to see that. And reduce risk of error. As I said before, we contain it within our facility rather than have it go outside. We've had some horror stories in the past of outside machinists where they've had nightmarish runs that have caused tremendous problems for us. I think we can get it quicker to your door. One of the objectives is always just in time, and our goal is to do it as fast as possible. Integrated components, assembly. We conduct a little bit of assembly here. We're certainly open to other assembly ideas, and always an opportunity to further streamline and add value within our operation rather than sending it out. So, horses for courses. It's a phrase that could be used to describe how PM is. For some people, one man's junk is another man's treasure, that type of thing. Certainly, it allows for us to generate components that meet the customer's requirement. We like to think outside the box. We like to look at how cheaply we can do this for our customer, because they certainly need it. Because their customers usually demand it as well. And ultimately, the goal is to keep the cost down with the best possible quality. We can select specific materials for the application. And then where it makes sense, we put in secondary finishing. You may need to have tolerances. As I showed you before, that component that had been pressed and then significantly machined in the raw state or in the rough state was for durability. You couldn't manufacture a part that would hold together without having some machinability, as well as cost and productivity benefits in terms of no outsourcing, so the logistics are simpler. They're all here. The service is out of our facility, and quality is maintained through our facility. The next step is the most important one for Centrus. Let's talk, the sooner the better. It's very important that the earlier in the design stage we can get to you, the better we can make your component. Usually the less expensive we can make your component, and more often than not, more manufacturable. They all go hand in hand. So the sooner we get to the customer, and the sooner we can work with engineers to develop the component, that is the best possible opportunity. And it allows us for cost and quality improvements using different materials that may be better than other ones specified. We've had cases where people have come to us with materials that have, been, let's call it, less than ideal in our view. However, they've already been specified, so we're stuck with these materials, and they have their inherent problems. whereas if we get the opportunity, we can perhaps recommend something better for the application. Sinter hardening is a good example of that, where we've had customers that have specified through hardened components. We'd like to move them to Sinter hard, but now it's locked in, so you can't change. And if anyone has any questions or comments, please feel free to enter them. Rick is available to answer any questions, and certainly we'll call you back if you need to and do anything that we can. I'd like to thank everyone for attending. Secondary finishing is the icing on your powder metal cake. And again, Sinter thanks you, and certainly we look forward to working with you in the future.